Hello everyone. In this video we're gonna look at the analog to digital converter, and we're gonna break it up to three parts: the bit depth, sample rate, and we're gonna end it with a small example in a simulator. I took this photo just of the idea of a very basic signal flow. We have the microphone here that turns the signal into electrical signal or audio signal, and it goes to the analog to digital converter, and out we have digital numbers or data, and that data gets taken to the digital system, our computer or DAW, and there we can progress it. We can send it back out to a digital format that goes into digital analog converter that takes the signal, turns it back into analog signal and out in our speaker or headphones. Now I like to take a bit of a time to introduce myself because I had a little bit of a time zone problem on the first assignment. So my name is Production Berklee. I come from Iceland, which is here. I live in Reykjavik at the moment. This photo is actually taken about 2 weeks ago, and as you can see it was snowing on it. And back the big church there is Hallgrímskirkja, where you can see it from many places in Reykjavik, and my school is actually just next to that. And here is a photo from my school. I am an electronic technician, and as you might see here I have a scope here and power supply up here, and I'm actually just looking at the frequency coming from this light source. I was having some flickering problem with camera, and here you can find some contact information where to find me on the internet. Now back to the AD converter. The first thing we're gonna look at is the bit depth, and the bit depth we can look at that relation between the amplitude or the y-axis with this axis here, as we know from math. Here we can see 1 bit that is basically just on and off, and 2 bits you get a little bit more. You get like 4 values, and 4 bits you will get 16 values, and 16 bits, and on and on. So here we can see really how it works. Here we have 8-bit and 16-bit here. So this is related to the dynamic range of what we are recording, and I think we notice this mostly when we're like listening to something that might have a kind of a quiet part, from whispering or orchestra or something like that. Then you can like clearly hear the difference between 16 bits and 24 bits. But like where the music is really loud just most of the time, this is very common, like in if you heard of loudness war, then the difference is like less noticeable. Next photo I want to show you is like the progress between the output code and the analog input. So if this would be the most signal we could get here, maybe, I don't know, 2 volts, then we would get a data output code like 111, and this would be a 3-bit word length, which would give us 8 values. And here on the other side, if we get 0 volts, we get 0 out of the converter. And in between here, like 4/8, we would get the number here 4 out. So it's a good photo that shows like what is coming in and what we get out of the converter. Now this is, as I say, just related to the amplitude. Now if we take a look at the sample rate, however, then we're looking at the time axis. And I just wanted to show this photo here because this is like some engineers, they don't like this a kind of a square drawing of a sample, they much more prefer like this. And it's true because like in between those 2 points we don't really know where the speaker or the data that we're collecting, we don't really care about it. And I just wanted to point out this awesome video here on YouTube. It's 24 minutes long. It might be a bit of in-depth, but it's really good and explains it very well. Now, when we're taking samples that then lower sample rates, then fewer snapshots we are taking, and the higher sample rate, the more snapshot we are taking. And we can relate this to like a video. If we are having high frame rate, that means like high sample rate, and lower frame rate means lower sample rate. And however, the bit rate would be like the resolution on the pixel size of the movie. Now, I just wanted to show you here with this small formula down here. It's how we convert the frequency to the time domain. And I just wanted to point out that like we're taking like 48,000 samples per second, and that is like one sample per 20 microseconds or 0.0 milliseconds. And that's a really short time. And here you can see if we have 22 hertz, that's like 46 microseconds that we're taking samples. Quite interesting. Now, I wanted to end here to show you like a AD converter, what it looks like. And we're gonna go to this site here and take a look at it. Now here we are on the site, and I'm gonna refresh it. You might get some Java problems here and configure it just and allow the site to work. Now this circuit just pops out automatically. But if you go here to circuits and down here to analog to digital and just go to the top one, we have a couple of, we also have DA. I'm not gonna show you those now, but let's click here. And this is just one example of what a analog to digital converter could look like. And here we have 7 volts here, and these resistors are basically just breaking these 7 volts into sample points on each leg here. This is a operational amplifier, and up here we have a 50 hertz saw wave where you can see down here. And as you can see, this saw wave is constantly going up to here around let's see, can see that it's going max voltage 3.5 volts. And on the other side here, this is the output of the AD converter. So as you can see, if I stop it now, we can see this point here where we are at 0, we are getting low out. So as you could relate to the photo I showed you earlier, that would be like 0 volts, so we get like 0 out. But at the top here, where we're in the maximum voltage, and that's the point here, every output is in high, so that's the highest state. So on this side here we are having an analog signal, and through this progress here we're converting it to the digital signal. And so if I would run it here, we could take the sample rate that I would write down these values every 1 second, like tuk, 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 something like that. And that's something I think my brain power could work out. But 1 second, that's 1 hertz, that's nothing comparing to the computer. So if I were to take this like 48,000 times per second, I'm not sure my brain power could handle that. Well, I look forward to see your videos, and good luck.